Welcome back, guys. We're going to start our lesson on normal distributions, which is 21.2. So the main essential question is going to be, how do you find percents of data and probabilities of events associated with a normal distribution? So basically, what is a normal distribution? It's the shape that is symmetric. So we talked about the shape of distributions in the last lesson. We looked at skewed or symmetric. The symmetric is the normal distribution. Okay, so when do we actually use that? All right, so here you could substitute a normal curve for a symmetric histogram. So this is just an example where they've got the mass of 20 babies at birth, and they're going to do a frequency bar graph of it. I'm just going to show you what it looks like. All right, from the calculator, it would look like this when you get your frequency bar graph. And this looks like a symmetric distribution. Right? The mound is in the middle, the tails are equal lengths, but this was only the data for 20 babies born. If you took all the babies born in Massachusetts in the month of March, you would have a lot more data, and then you would get a shape that's more curved. All right, so that's what the normal distribution is going to be. So we're going to talk about probabilities and percentages. Okay, so this is a very popular concept called the empirical rule. I think in the homework, it talks about the 8 symmetric divisions, all right, of the graph, and we'll talk about that. All right, but we're going to talk about finding the area under a normal curve. So we have this empirical rule. It's called the 68, 95, 99.7 rule. So a standard normal curve centered at the mean is going to look like this. So there's your bell-shaped curve. And then whatever the mean value is of the data, we put at the center. So this is our symbol for mu. And whatever value for your data is the mean, that value would go here. Then, as you move outside of the mean, so if you move 1 sigma to the right or 1 sigma to the left, remember sigma is the standard deviation. So if you're given the mean and the standard deviation, you can find these values, right? You put your mean here, you add your standard deviation, you subtract your standard deviation, and you'll get 2 new values here. And the rule is that 68% of the data will fall between these two values. All right, so 68% of the time you're going to have values that fall between these two. If you're doing a probability, we would say the probability is 0.68. All right, so when you're doing the homework, it's going to ask you certain questions. It might ask you for the percentage or it might ask you for the probability, but you just have to write the percentage as a decimal if you're doing the probability. Now, if you go out 2 standard deviations from the mean, all right, so if you add another sigma to this value and subtract another sigma here, then this would account for 95% of your data. So 95% of the time, data will fall between these two values, right, if you have a normally distributed data system. And then for the third, 3 standard deviation, that's going to be 99.7. So outside of that 99.7, it would just be 0.3%. All right, so very unlikely. So this is how they find the likeliness of data. One of the concepts they put in was body temperatures. And when you're taking temperatures of people, when you have enough data, all right, thinking about 98.6 maybe being in the mean, all right, if your temperature is, more than 3 standard deviations above the mean or less than 3, then there's cause to be concerned. All right, so that's what we use it for, to find data that's unlikely. So we can actually break this up into 8 separate portions, all right, 8 symmetric portions as well. And that will give us this distribution. So if you notice, because this curve is symmetric within here, since this was 68, we divide it by 2, we get 34. Then within this, the 2, that was 95% of the data. But then you can subtract the 68 and then divide by 2. That means each one of these portions is 13.5%. Same thing over here. We could take the 95 and subtract it from 99.7, divide by 2. And then we said 0.3% would be at each tail. So when you divide 0.3 by 2, you get the 0.15. All right, so this is how your data would break down. So let's look at an example. So this says that suppose the heights in inches of males in the United States between the ages of 20 and 29 are normally distributed. That means we can draw the normal curve with a mean of 69.3 inches and a standard deviation of 2.92 inches. Find the percent of males that are shorter than 66.38. So when you're doing problems like this, and this is what most of your homework problems will look like, you want to set up a normal curve, all right, and put your values. So we've got 69.3 is the mean, 2.92 is the standard deviation. All right, right, so I just want to show you this. I'm going to put a blank normal curve, post it on Google Classroom so that you can use it to help answer your questions. So it said, what percent fall below? I believe they said 66.38, which is right here. So again, using what we know about the percentages, what percent falls below, right? 66.38 would fall here. So we'd have to add up all these percentages. So the 0.15 plus 2.35, that would give us 2.5, plus 13.5 is going to be 16%. So let's go back. All right. So 66.3 inches is blank inches below the mean. Okay, so this is just actually finding the difference. All right. So that was just exactly 2.92. All right. So that was one standard deviation from the mean, so that was 2.92 inches. So we're going to go here and we can type in our 2.92. This is how many standard deviations? That was exactly one standard deviation. Let's check, and we're good. Now it says to separate the area under the normal curve into 8 parts as above. Select the areas of the parts that satisfy the given condition. So the given condition, percent of males that are shorter than 66.38. So again, shorter than 66.38, we said we're adding up these 3. So the 0.15, the 2.35, and the 13.5. So the 0.15, the 2.35, and the 13.5. We'd be adding those up. And that's correct. The sum of these percents is, we said 16%. So we're doing 16, not 0.16. So 16% of the males are shorter than 66.38.